Hey guys, today we're going to be talking about ions. So let's real fast review yesterday's stuff. Okay, so here's the chart. So protons have a 1 charge on the nucleus, mass of 1 AMU. The job is it determines the identity, it's the atomic number, neutrons, whatever you can see. You find neutrons by mass minus atomic number. Ions actually have to do with electrons, so that's technically not right anymore. It's only the same as, well, actually, let's edit this. It's the same number of protons, same as the number of protons in atoms. But we're talking about ions, which is something different. So, oops, it said for now. Okay, so what is an atom? Atoms have no charge. They have the exact same number of positive and negatives, which means protons and neutrons. Oh, that's what the... Therefore, electrons are equal in atoms. Protons and electrons are equal in atoms. So that's going to be your giveaway. If you see the word atom means no charge. Protons and neutrons and electrons are equal. But as soon as if you have more or less electrons than protons, you have a charge. It's called an ion. More about that in 2 seconds. So, ion. How does ion happen? An ion, atoms don't ever gain or lose protons or neutrons, but electrons are gained and lost all the time. Why are electrons and things? Why don't you ever gain or lose protons and neutrons? Because they're in the middle, and the nucleus is so tiny. Remember Marble in Arrowhead Stadium, and they just never get close to each other. So like, here's my cheesy video. So here's a lithium atom and a fluorine atom, and if they move close to each other, like, the only thing that overlaps are those electrons. I realize that's the not right model, but that's what I got. It was easiest to do. So the nucleus is right in here, like, they're not going to get anywhere near there. They're going to hit the electrons and just like bounce off because they're all negatives and the same charge repels. It just doesn't get to the nucleus. This is my visual as to how things become an ion. So this is lithium and fluorine again, but as an atom, 3 protons, 3 electrons. Fluorine has 9 protons, so it has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 electrons, right? So in that, how do things become an ion? When these 2 things get near each other, I should have had them closer, but whatever. In a chemical reaction, the reason why the shell thing is an electron model is that it's really convenient. Instead of having to draw like, one of these electrons is in this shell, and then the other 5 are in these shells, one's here, and one's here, and one's here. Like nobody, you don't have to, that's why. Shells are just convenient to draw. So what happens is this electron is lost from over here and it moves to fluorine. And so now this is what it says. So now, I'm not going to click yet. I guess I can. So lithium lost 1 electron, becomes a 1 plus ion because now it has 3 pluses and 2 minuses. So 1 plus ion. Fluorine then now has 9 protons, but 10 electrons. So it's got 9 pluses and 10 minuses. So that means it charges 1 minus. So another symbol information. So now we have our symbol again. So now when we see the symbol, we did this side the other day. Today, ion charge will end up being protons minus electrons, and we'll talk more about that in a second. Ions are a lesson in thinking backwards. These were supposed to pop up all at once. So suppose an ion has exactly 1 more electron than it does protons. If it has 1 more electron, 1 more negative, it's going to be negatively charged. Yeah. If you lose 2 electrons, if you give away 2 electrons, that means the 2 negatives left. So it's going to basically positively charge. So the most important part, when you have more electrons, it's negative, which seems backwards. That's why it's thinking backwards. You have more electrons, that's going to be a negative charge. You have less electrons, that's going to be a positive charge. So keep going. okay, so the chemistry book definition of an ion is an atom that has either gained or lost electrons. Or the shortcut definition of ion is a charged particle. Something that has a charge is an ion. If you gain electrons, you become a negative ion. If you lose electrons, you become positive. So again, backwards. Gaining is negative, lost is positive. Fancy words for negative ions. Anion. A negative ion is called an anion. And how do I remember that? A negative ion. If you lose an electron because of positive ions are called cations. And again, see my cheesy way to remember that one? Ca, the T looks like a plus ion. A negative ion, Ca plus ion, cations. I realize that's cheesy, but that's how I remember a negative anion and cation. Okay, so here's now our examples. So just like before, I'm pretty sure these are the exact same. Remember, the bottom number is protons. To find the neutrons, you just subtract those two. So that's 16. And now electrons is, okay, now I always try to think about this logically. If you have a 3 minus charge, that does not mean that you have 3 less electrons. You have 3 more electrons because it's a negative, right? So, oops, that one, whatever. Negative means, so then, well, that's what. Negative means 3 more negatives. So more, you're never, ever going to change protons. And I think I say that in a second because they're never gained or lost. Protons are, and because they're so right there in the middle. Okay, so 18. So that makes that 18. 3 more than 15. So that's actually this first one. So again, negative, that's supposed to be negative. Like negative ions have more electrons than protons. This one then, iron, is positive. So protons, again, the bottom number is protons. Should have done the symbol slide. Neutrons, you subtract them. So whatever 54 minus 26 is, 28. I don't remember. 54 minus 26. Yes, 28. And then, okay, so 2 plus. So I have 2 more pluses than I do minuses. So 2 more protons. And you're never going to change that number. So that's why I kind of put them in that order, because you do protons first. Don't change it. Electrons is what changes. So 22 plus, so that's 24. Great. So then the next little thing is positive ions have less electrons. Positive ions less than protons, so less. So then calcium, okay. Never change the number of protons. It's the only particle that doesn't change. Yes, so I said that. Oops, no, let's do this one. So protons, 20. Neutrons, 21. Electrons, 2 plus, so 2 more positive, so 18. Yay. Okay, next slide. Hope that's not too fast, but here we go. I really like this one. So this is kind of like the summary with all the words. So if you change protons, you change, I should have popped these up all at once, but that's not how this works. If you change protons, you affect the identity, and the result is a new compound. If you change neutrons, that just changes them. Well, here, let's do it. So protons changes the identity. That's going back to the job of the subatomic particles. Protons is the identity. When you change protons, your compound changes. You get a different atom. Neutrons just changes the mass. When you change the mass, that's called an isotope. If you change electrons, you have a charge, and that's an ion. So here's our 2 I words. Isotope is all of these are the same elements, like neutrons and electrons. Yes, there's those 2 I words. Isotope, same element. Ion is still the same element, it just has a charge now. Okay, so let's do a couple more examples of counting. This, by the way, if we were to be in class, would have been on a test, but since we're not, it's not going to be. Well, actually, the quiz is going to be tomorrow. It's just this. It's just counting all these 3 examples. Now with electrons, just pay attention to whether it says atom or ion. But if it's a charge, that means... So I'm going to just fill this out. Let me pick a different color than red, because this is red. Oh, let's go purple, because I like purple. It might clash, but whatever. Okay, so symbol, nitrogen, and atomic number 7. So remember, atomic number is the same as protons, so 7. But now you got to do a little bit of math. Neutrons is still mass minus number, so that's still 7. Now electrons, to do electrons, you have to look at the charge, because the charge is an imbalance of electrons, which is why it's next to there. So now 3 minus 3 negatives, 3 more negatives than positives. So that means 7 plus 3 is 10. So what's opposite? Ooh, let me go back. Okay, I'm gonna go back. Remember our symbols? Okay, so here, this is why I did protons minus electrons. When you do protons minus electrons, if you have more electrons, when you subtract a bigger number, say you have, well, we just did it. 7 minus 10 is negative 3, right? So like, and then if you were to charge equals, so like, funnily enough, rearranging the equation, charge plus electrons equal, whatever, I'm not going to rearrange. But I just think of it in terms of positives and negatives. If you have more positives, then you have protons, you have less electrons. If it's positive, you have more protons. If it's negative, you have more electrons. Never change the protons. Okay, back to the chart. Okay, so this one I left the substance and symbol blank. How do you know what the substance is? You look at protons. So 47 is silver. You can't really see that on top of there. All out of the screen. Just do that. So silver. Then I'll go back to the purple. Is Ag. Atomic number is the same as protons. 47. Atomic mass. Funnily enough, then for the atomic mass, you would add those two up. So 47 plus 63, I think, is 110. 110. Charge. Protons and electrons. You look at protons, those are the things that have charge. These are a plus charge, these are a minus charge. So I have one more positive than the negative. That's a 1 plus. Chlorine, symbol Cl. Atomic number is 17, so that's protons is 17. Neutrons, 17 minus 36. Well, I said that backwards, but whatever. 19. So that means that one more negative than positive. It's a 1 minus. Nickel is a, well, whatever. Symbol Ni, 28. Atomic number is 28, so it's got 28 protons. Mass, add those two up. 28 plus 31. 59. And number of electrons, 2 plus, so I have 2 more positives, so that means I have 26 electrons. Hopefully that's not too much, or too fast. Again, draw the symbol. So again, protons are what the identity are, or what the identity of the atom is. So I always start with the symbol. So 16 protons is sulfur. Sulfur, down here is the atomic number. So 16. Atomic mass, then you would add those two together. Plus 17, 33. And so now the charge, I have 2 more negatives, so that's a 2 minus. So literally that's the only difference from yesterday. 19 is potassium, so that would be K. Yeah, we're going to do the same stuff on the quiz, but it's going to be multiple choice. So it'll probably be, yeah, anyway. So 19 down here, 19 plus 20 is 39. There's one more proton than electron, so that's a 1 plus. And technically it doesn't matter whether you put the plus or minus behind, but you have to put a plus or minus in there, like more positives than negatives. And I think that's, yep, we're going to add on to that. So there we go. There's the end. Hopefully you got it. I got 30 seconds to